Hello, good evening all. Just please check I am audible to you.
Yes, you are audible.
Yes, it's audible. Yes, sir, audible.
Yes, thank you. So, welcome to you all for our today's webinar. We will start in some time because crowd is joining. First of all, I would like to welcome our today's guest, Nishat Patil sir.
Uh, Thank you, Rohan. This is Nishat. Hope I am audible.
Yes, sir, you are audible.
Great.
Yeah.
So,
Yes, we will start in 2 minutes. The audience is
all right.
joining. Yes.
All right. Yeah. Very good evening to all.
Yes. Yeah. Good evening. First of all, welcome everyone. I am delighted that you all have joined today for this webinar. Thank you for giving us your wonderful time. This will be an opportunity to learn and grow in your career. For those who don't know me, I am Sudarshan and I will be your moderator for this webinar. We from Whole Beginnings organization team welcome you all for the webinar. Always remember, career is an ocean to sail and this wheel is in your hand. The experience makes you the right captain, and one right captain can make hundreds of more capable captains. No captain is self made, one needs to sail the ocean in the shadow of a great captain to get experience. There are lots of key lessons you need to learn from great captains in the field to sailing, and one of them is a petroleum refinery. So for that, we have a very experienced captain on board. Let's take a moment to introduce our guest speaker, one of the great captain in this chemical engineering ocean, Mr. Nishat Patil. Sir is an experienced personality in multinational business, process technology in oil and gas, and petrochemicals. So without further ado, let's start. Nishat sir, the audience is yours.
Uh, yeah. That's a great introduction. Thank you, Sudarshan, and
Yeah,
thank
welcome
you,
sir.
thank you, Beginners Organization team for giving me this chance to interact with the young engineers, chemical engineers. So I passed out from ICT in the year 1999. So it's long back. Uh, It's been more than 20 years in the industry. So it's been a great time learning a lot of things, not only into oil and gas, but into several other processes, simulations, energy studies. Uh, uh, I'm an energy auditor as well. So the BEE, Bureau of Energy Efficiency, they conducts these exams, and that's a beautiful course laid out by BEE. So any of you uh, would like to do something in the field of energy, I recommend doing this course. There are four subjects, and then there's a lot to learn. So, well, that is not really related to today's topic. Uh, but in like I guess I think there are more than 50 participants in today's meeting. So that's a very good audience, and I guess we have around 1 hour 15 minutes time, uh, and then we'll keep some 10 minutes for question and answer at the end. But what you can do is you can type your messages in the chat box if you have any questions, so that at the end, uh, you know, I can go through those questions one by one. I hope that is all right with everyone. So today's topic is very vast, refinery. So when I got a chance to work with one of the biggest oil refiners, Indian Oil Corporation Limited, just after my engineering, I was very delighted because I had seen those pictures of huge complexes and the towers, the distillation towers, the stack, and the lighting over that. You might have seen those pictures. So that excited me. Okay, I'm going to join this prestigious organization, and yes, I enjoyed a lot. I was at uh, Panipat Refinery most of the time during my 6 years of tenure in refinery, where I worked in shifts, groundwork, basically in production. I actually opened valves, closed. I did participate in startup, shutdown, all field activities, and that is a very well experience. So, those who want to make their career in industry, I would recommend you start. You spend few years in production, because there you get that experience, and you can visualize things better way. Otherwise, if someone has not seen plants, it is very difficult, when you uh, grow old in the industry, and then it is very difficult to visualize things. Once you are there in the plant, you have that experience. Anyway, so today's topic, refinery, is a very vast topic. I really don't want to go deep into the subject. Uh, that will take a lot of time and maybe an entire day. So I have few slides, so I don't really want to bore you. The purpose is that we will keep it short and sweet, and you will enjoy this session. And I have few links, few references that subsequently the team will share with you depending on their protocols. Uh, so, uh, yeah, so atmospheric distillation. Yeah, all right. So, CDU video is the mother unit, guys. So CDU is also called as atmospheric distillation unit, and video is vacuum distillation unit. Okay, so I'll go through this one by one, but let us not jump to the CDU. Let us understand what it is, what actually, right from the beginning. Uh, Let me know my screen is visible. I have into PowerPoint mode. Sudarshan.
Yes, it is
Yes.
visible.
Okay, all right. So this is the cover page. So what I intend to cover today is you know uh, crude oil, because this is the starting point. What is crude oil, and how do you what are the different types of crudes? And as you may be knowing that crude oil is there inside the wells, on the surface or inside the ocean, or the shale oil. So there are different sources and there are different crudes. We will have look at it one by one. Refinery, what is the purpose? What is a typical configuration of a refinery? Yes, then we have chemical engineering, unit operation, Maccabe Smith, and all other books that you might have referred in your engineering curriculum. So one is unit operations, like most important. Then there are n number of oil refineries, across the globe. So we'll look at some of those names, which are the biggest oil refiners in Indian continent and global companies. Then yes, so we have raw material which is crude oil, and then we have various products, and of course there are specifications to each of these products, because when you want to sell any product in market, it has to adhere to those specifications. Otherwise, buyers will not buy that product, right? And then further reading and resources. So I have some, and but the list is not limited to that. The internet is nowadays it's open to all, and you can really go. Yeah. So crude oil. So what is a crude oil? Those are very complex mixtures, years together, hundreds of years, those are formed beneath the earth, beneath the ocean. Okay. And as you know, Saudi Arabia, the Middle East region was highly concentrated. Like uh, the richness that those people have got in the history is because of oil. So oil was discovered at many places, but that region was that has been blessed by God. So the crude oil wells are like they are those wells are never going to get dry. But situations change, and today you see U.S. America, who was like importer of this crude oils, heavily dependent on Saudi Arabia and other regions. They are now exporter. There, there is no need to import because they have discovered shale oil. So the R&D plays very important role, because it is all probability. Because basically there are three regions: upstream, midstream, and downstream. So when we say upstream, it is crude oil exploration. So uh, uh, there are wells, and so every well doesn't have oil. Okay, so people invest into it, the businesses invest into it, but there is a probability. Not everything is going to yield crude oil. Okay, so there are many big companies, there are many big corporates: ExxonMobil, Shell, British Petroleum, Equinor, Total. So these are all global companies. In India, we have ONGC, Oil and Natural Gas Corporation, which is in the upstream space. That is exploration, crude oil exploration. Midstream is something you should just share the or the separate the feedstock, and that feedstock is used for different purposes. And downstream is refinery and petrochemicals. Okay, so yeah, refinery configuration we are going to look at, and nowadays it is refinery and petrochemical integrated plants, which can make most profit, because having a refinery alone does not make sense economically these days, because the plastics, the polymers, the petrochemical downstream is infinite. If you ever get to chance, that there is a tree diagram of this crude oil, and then there are n number of branches. So if you look at this diagram, which is available on the internet, you will come to know there are n number of molecules, and each molecule can give you 5, 10, 20 number of products. So there are aromatics, there are polymers, uh, and specialty chemicals. There are many, many things. Okay. So crude oil has a wide variation in composition and properties specific to the field of origin. What it means is, say, African crude will have different properties than the Russian crudes, right? Or the crudes that those are found in Arabia, those would have different properties, right? So how it is classified? So on a superficial level, I would say it is about PONA, that is paraffin, olefins, naphthenic, and aromatic. It's called as PONA, PONA. So what is like crude, whether it is like mostly paraffinic, naphthenic, aromatic. So that is defined by UOPK factor, right? So I'm not giving each and everything on the slide because the slides will run into hundreds. So whatever you find new terms, just jot down in your notebook. After this session, search on the internet what is UOPK factor, or some of you might have already got this answer. So, you know, so UOPK factor gives an idea like what kind of crude it would be. But alone UOPK factor does not define the crude. The crudes are sour or sweet crude. Sour is like high sulfur. So sulfur is or sulfur compounds. Those are present in the crude. If those are on higher side, that's called a sour crude. And if it is sulfur content is very low, it is called a sweet crude, right? Okay. The sulfur ranges, like it could be like 0.1% to 2%, 3% in the crude. So if it is very less, that sweet crude could be costlier than the sour crude. So it's not that all crudes are sold at same price. Now, why sweet crudes would be costlier? Because in the refinery they will need less treatment, less utility consumption, less hydrogen consumption, less catalyst consumption, right? Because you might be knowing this BS3, BS4, BS5 specs, which are on the sulfur. So earlier it was like maybe 500 ppm was allowed. Now that has come down to 50 ppm. So if you have a car and then you are having this emission test, so all the petrol and diesel, those are sold at the petrol stations. Those are like BS4 or 5. I don't remember, but that's the latest spec. So the sulfur is brought to the minimum because pollution is rising. You know global warming, right? So lesser the sulfur, it is better for our environment. It will get pollute less. So that's why these harmful toxic gases, those are released into the atmosphere through vehicular pollution, gets reduced if we have sweeter products from the crude oil refinery. So the emission due to vehicular is the most dangerous because it is huge in quantity. Every household has got a car, right? And there are heavy vehicles. Still, we are dependent on like this trucks transportations and everything which use diesel, and some of these vehicles are way old, and so older vehicles they pollute more, right? Then light versus heavy crudes. So light and heavy is like, as the name goes, it is about the density or specific gravity, or it is called as API. Okay, so API is inverse to specific gravity. So if I say higher API, which means lighter crude, and lower API means heavier crude. So API, there's a formula to convert specific gravity into API, which is a simple formula. And then you can convert specific gravity to API. So most of the times, crude density is, crude is called in terms of API. So what is the API for crude? What is the sulfur content of the crude? then whether it is highly acidic in nature, what is the metal content in the crude. So metal is in ppm. It is not like metal is in like tons of it's not in the crude like, but it is measured in ppm or some of these. So nickel or vanadium, these are the commonly found metals. So now how do we know, like, we have a crude. Now, how do we know what that crude contains, right? uh, इतना सारा इंफॉर्मेशन कहाँ पे मिलेगा?
Hello, sorry for the disturb. Nishat sir, your mic is mute.
Oh, sorry. So, oh my God, I'm very sorry. Uh, I, I was speaking this past, I don't know, 5-10 minutes, and then sorry, Sudarshan. Sorry, guys. Let me start all over again. So, is my screen visible?
Yes, sir.
Yes, sir.
Yeah, very sorry for that. Uh, so this is the. So, did you hear anything, or it was all like, I don't know when I pressed mute. Uh, so ये स्लाइड का सुना
No, sir.
सबने? नहीं? अच्छा,
Yes.
ओके
Actually, we
ओके
heard till how to determine whether the fruit is sour or sweet.
ओके ओके and then after that it became mute.
Yes.
Okay,
No,
okay, then
no, no.
it's all
It was working like API. Cloud.
API.
Yes,
Yes, sir. Yes.
API and
Absolutely.
specific.
Okay, okay, so I did not mute. I think some maybe any of the organizers
Some technical glitch was there.
by mistake put me on. Okay, then all right, no problem. So yeah, so I was talking about API, the light versus heavy crudes. So API is basically density uh, in some other form, okay? And it is very convenient to
Yes,
express that in terms of API. And hence, that is the commonly accepted terminology across the crude oil world. So higher API, which means lower density, light, and lesser API means heavier crude. So it is reverse of specific gravity, right? So always keep that in mind. Now, all this information, density, sulfur content, acidic, PONA, whether paraffinic, naphthenic, aromatic, where you are going to get all this information. So these corporates which deal in the crude oil business, they publish this crude assay of their respective exploration sites on their website. Now, some of these assays are not published if that information is confidential. Say if they have found a new field, a new crude, then they might not publish it immediately. They will take it to the market, and that information may be sensitive to the business. But most of the old assays, crudes which have been used by years, over years by many refiners, those are available on this website. So I have listed three, but there are many. Okay. And you may be aware of simulation softwares like Aspen, ISIS. So these softwares, they have crude as a data bank. Okay. So they have all the information in there inside the simulation software in the data banks. So one can just simply select the type of crude, and that already has the information built in inside the simulation model, and you can create a stream out of that crude. So you can say, okay, 10,000 barrels per day. So that stream is created. And then once you click to the properties, you will get various properties. I will go through those properties. What are those important things that you have to look at in a crude? So let me just open few of these, say maybe Exxon Mobil. Is this visible
Yes,
website?
it's visible.
Okay, okay.
Yes.
So
Yeah,
Yes.
you are
yes,
visible.
now here you can see a list of crude oil by geographic location. Europe, North America, South America, Asia Pacific, Africa, Middle East, Central Asia. In Europe, you will find country-wise. So in Norway, ExxonMobil has 33639 11 sources. In United Kingdom, there are five. North America, Canada. Now the Canadian crudes are different crudes. Those are like dumper-like crudes. Sand crudes बोलते हैं उनको. So those are heavy crudes, and so that those needs different treatment. Okay, and this particular region, which is on the northern side, Canada, North America, that becomes very cold at times and at freezing temperature. So movement of these crudes through pipelines becomes very challenging. So every geography in the world has their own challenges. Okay, United States, you can see so some uh, uh, peculiar names, and I don't know who named these crudes, but say Elisa, Unity Gold, Gippsland Blend. So blend is like there may be some multiple sources of crude, and then those blends, and ultimately you get some resultant composition. In Africa, you have at Angola, Chad, Equatorial Guinea, Nigeria. Nigeria has got crude assays. Middle East, Azerbaijan, Iraq, United Arab Emirates, Yemen. So those are no different examples. So let us see any of the say Indonesia. Okay, and I open this Banyu Urip. This is one type of crude. Now under this you will find a lot of information. So what this says is how much quantity is produced. Okay, say 400 million barrel, say field. What is the potential? Then from when it started, load pole, typical characteristics, gravity 32, sulfur 0.3%. And then you'll find assay here, right? In PDF file or Excel file. So if you want to copy and paste that information, you can download Excel. So suppose I download the PDF file now. Okay. So this is a typical example. Now this is one page. Other companies may have it multiple pages. Now what do you see here? You see different cuts, whole crude, butane and lighter, light naphtha, heavy naphtha, kerosene, diesel, vacuum gas oil, vacuum residue. So I'll cover this, but essentially what it is every cut is defined by the distillation points. So this is IBP and FBP. So for example, the initial boiling point is 480 degree Fahrenheit and final boiling point is 650 degree Fahrenheit. So diesel obtained from this crude, suppose you have a atmospheric distillation tower and you heat this crude to a temperature where it flashes, then you will get these cuts in the tower. The top of the tower will give you this lighter one. Below that cut, you will get light naphtha, then heavy naphtha. Below that, you will get kerosene. Below that, you will get diesel, then VGO, then vacuum residue, right? So these are, you know, uh, typical terminologies. As I told you, is a API gravity. Now you see it has got an API gravity of 32, and all products are also there in API gravity. The specific gravity is there. So if you see, the heaviest vacuum residue has the least API, 13, but in terms of specific gravity, is the heaviest. So, as I told you, this they are like rivers. So, low API is high density. Then it has got carbon, hydrogen, pour point. So, pour point is the point at the temperature at which it would cease to flow. So, you need to maintain above that temperature to maintain the that fluidness of that liquid. Mercaptan sulfur. So these are different forms of sulfur. Viscosity is important because once the crude is found, it has to be supplied, right? It should go to the right destination. So it is not possible to fill the tankers and convey all the entire crude to that particular site. So many a times it is tankers plus the shipments through ocean. Uh, there are many VLCC, they call it that, very large crude carriers. So they carry millions of barrels in it. Then the piping through pipe, the crude is transported, or all these products are transmitted transported. So in India, IOCL has the biggest piping network spread out across the India from Kashmir till Kanyakumari. So very complex piping. It is spread all over the uh, India. I told you about the metals. These are the different metals here, and this is the distillation. So how these properties are obtained? They take a sample of crude and the laboratory. They get it to a laboratory, and then laboratory conducts the distillation. They note down these observations, and several tests are conducted. And so there are specialized laboratories who will get these assays to this ExxonMobil or other companies, right? And they have various gas chromatographs. The common method of distillation is ASTM, American Society. Uh, I forgot but anyway, it is ASTM distillation method. Uh, and there are many distillation methods because not a single distillation method would suffice for all the cuts. Vacuum residue will have different procedure of distillation. Naphtha has a different procedure. Diesel has a different procedure. So there are different protocols which are widely accepted across the world to know these properties and how laboratory should be uh, measuring this and noting down. Okay, so now let us see another crude. Okay, maybe those who like Canada, let us go to Canada and say Cold Lake. Let us see how the Canadian crude looks like. So I open this page. Now you are familiar with the overall layout, right? How the assay would look like from ExxonMobil. So once you start looking at 3, 4, 5, 10, you'll get comfortable. Okay, this is the information published. Then you will have confidence. Uh, okay, ऐसा होता है. All this information is published. Okay, so yeah, similar pattern, whole crude, and then what are these cuts and everything. So if you see, it was like now vacuum residue. If you see, it is 1 and 1.068, whereas the earlier crude it was 13 or something. So can you notice the difference? This is just one number. All numbers are different. If you compare these crudes, you will come to know. Then sulfur is there. CCR is another important parameter. It is called as Conradson carbon residue. So basically, when all the if you burn this crude oil, okay, till it only char is left on that pot, and then whatever is left, that is the weight percent. So if I burn say 1 kilo of this crude, then the 10% of it, which is 100 grams, 100 grams will be the carbon residue left on the pot. So this is called a CCR. I just told you simplistically. It is not that simple. It has got uh, good equipment, apparatus. You might have seen few apparatus in your laboratory in engineering colleges. RVP is read vapor pressure. This is also important. So vapor pressure is important because, say, if you have a tank in which some hydrocarbon is stored, right? So if it is storing naphtha, naphtha is a very light component. It has got higher vapor pressure, which means it will keep pressurizing the tank because the higher vapor has formed. And as summer, in summer times, it will vaporize more. So more vapor pressure. So more vapor pressure means that storage tank has to withstand that much of pressure. So the design of this storage tank has to be like that, that it should withstand the pressure. Now there are floating roof tank and fixed roof tank. Floating roof tank is like with the vapor pressure, the roof is like movable, right? Uh, anyway, that is a storage aspect. So I hope I have given you a glimpse of crude, how it looks like, and what are the properties of crude. So similarly, there is total energies. I'll just show you the home page of those. Right? So this is total energy. So these are all like exploration sites. It looks very beautiful. I haven't got chance to uh, be there on the upstream side. So here also you'll see the region wise they have classified. Say Middle East. In the Middle East they have Das Blend, Murban, Oman, Qatar, Marine, Upper Zakum. So these are the dates, and assay date is published, and then you can download this. So for example, I have downloaded now Excel. So in Excel, they have given similar information, just presented in a different way. So what you see is like what are the different fractions. So if you carry out the atmospheric distillation, so and these are the distillation ranges, then in this range, how much weight percentage of material you can collect. Okay, this is a cumulative percent. So and the rest is the residue. So for example, up to 200 degrees Celsius, you will recover 18 weight percent of that crude in a pot, or 23% volume, right? और 500 डिग्री सेल्सियस तक आपने निकाला तो आपको 70% वेट अराउंड मिल जाएगा मटेरियल और 74% वॉल्यूम राइट सो that's a very good information and then this is again a better assay than Exxon. See, there's a lot of information. So what they are telling you is that if you proceed this with crude and process this in a refinery, you will get this much of products. This is the yield of the products. How much naphtha you can get. What is the property of naphtha? What is the RON is a research octane number and motor octane number. Octane number is typically 9092. You might have seen in petrol pumps. So it gives you products, their properties. Fantastic, right? So this gives you a whole lot of information. And that's why I started with crude oil rather than jumping to what is a refinery. So here, once you are familiar with the crude, then understanding CDU and VDU and other units will be very easy. What CDU is doing is basically these are the cuts and the column is designed in such a way that once you remove out, there are different draws along the height of the tower and so the design is such that okay maybe say from the top on the 15th tray suppose heavy naphtha cut is taken, so the design is such that on the 15th tray this boiling material will come out in a pipe and then you will have further processing of that. Okay, then the laboratory takes samples, they collect, they check all other properties whether it is on spec off spec. Okay, so crude oil, you can visit and increase your knowledge. There's a lot of information available on the different websites. I hope I'm not on mute. Okay. Any questions here? No, so far. Last sentence was इतना सारा कहाँ मिलेगा? Anyway, okay. So this is a typical refinery configuration, right? So this is published by OSHA. OSHA is like the governing body in the US for safety and health. So that decides various audits to be carried out in the refinery and petrochemicals uh, to ensure that safety and health related aspects are maintained. So here, if you can follow my cursor, the crude oil comes here and there is a process called desalting. Desalting is very important because if this is not carried out properly, all other things will fail. Desalting is removes the salt, as its name suggests, desalting. So salt is removed from the crude oil. There are equipment called desalters, where electrical voltages, the currents are applied. So there are separate transformers, and through electrostatic precipitation and other principles, salts are removed from the crude, and the desalted crude oil is fed to atmospheric distillation. So this is the first tower. Is also called as a mother unit. So some of you have asked like ADU, VDU. So atmospheric distillation unit or crude distillation unit or atmospheric still. So there are different names. Some people call it a pipe still because it is just a pipe or a big pipe, but it is a tower, right? And it is typically a tray tower. Okay, there are wall trays inside or different other types of trays. Uh, so from this atmospheric distillation, the top is gas, right? Top will give you the lightest component. And then you see light naphtha, heavy naphtha, kerosene, middle distillate, which is the diesel range, and gas oil. So gas oil is just above the bottom of the residue. So this is called as atmospheric residue. The bottom of CDU is called as atmospheric residue. Now, this desalted crude, there is a long pre-train consisting of 30 to 40 or 50 shell and tube heat exchangers, because this crude has to be heated more than about 300 degrees Celsius, because only if it is heated, it will give you the separation in the atmospheric distillation column. So there are many equipments. It is not like it just enters the tower and uh, everything is done. Okay, that is not the way. This is just very simplistic block diagram. It doesn't have all the equipment. From atmospheric distillation unit, the bottom of residue goes to the vacuum distillation. So this has a very high boiling point. Now, if you keep on hitting this, you will have to spend a lot of fuel on this, and still you will not get proper recovery. So, as you know, the principle of phases, the if you apply vacuum, the boiling point is going to reduce. So you will consume less energy here. That is the same principle.
Sir, what is the
Uh,
composition of middle distillate?
Sorry.
What is the composition of middle distillate?
Yeah. So here in the refinery, composition is always in terms of distillation, IBP and FBP. So that there are different cuts. As I showed you in the distillation assay, naphtha will have some different boiling point cut. Kerosene will have different boiling point cut. So it is typically the carbon number and the boiling points which define. So for example, you have LPG cylinder in your at your home, or maybe at in town, or so that LPG cylinder is what? It is C3 and C4, right? Mainly propane, butane, isobutane. Then comes the naphtha. So naphtha is C5 plus. So naphtha will have some C5, C6, and within that C5, C6, there are many isomers. There may be paraffins, naphthenes, aromatics within the same carbon numbers, right? And say maybe up to C9 is all naphtha. And when you come to kerosene, it will have some overlaps, some C9s, but it will have up to C13, C14 carbon numbers. And beyond that, you have middle distillate. Then that increases like C16 till a very large number of carbon. And so the carbon number and the distillation point is the composition. There is no straightforward composition like, okay, this is 5%, this is 6%. No, it all depends on what is your crude. Okay, I hope I answered your question.
Yes, sir.
All right. So then comes the vacuum distillation. So you apply vacuum so that you can get most of the recovery, and that is called as the bottom of the barrel. Okay. So bottom of the barrel means जो भी बैरल मतलब एक पिंप और जो क्या बोलेंगे उसको डब्बा ओके उसमें कुछ लीटर ऑयल है नाउ यू वुड लाइक टू मैक्सिमाइज योर प्रॉफिट सो हाउ वुड यू डू इट क्रूड क्रूड से आपको मैक्सिमम प्रॉफिट निकालना है सो यू योर राइट हैंड साइड में जो प्रोडक्ट्स दिख रहे हैं व्हाट आर द प्रोडक्ट्स दैट यू आर सीइंग ऑन द राइट हैंड साइड दैट आर गोइंग टू गेट मनी फॉर द रिफाइनरी तो जितना ज्यादा प्रोडक्ट्स वी विल टेक आउट फ्रॉम अ रिफाइनरी will make that much of profit. And the heaviest thing, the vacuum residue, that is sent to de-asphalting and then some catalytic cracking, and that is also converted into some fuel oil. The fuel oil is the cheapest product from the refinery. It is used in the boilers or the thermal power plants where the fuel oil is fired. But fuel oil is a nasty because it will create pollution. It is a heavier thing. So most of the time it happens that fuel oil is not sold from refinery. So they have to identify buyers across different regions. So it is very, very, very dynamic. This all economic pricing and everything is very dynamic. So it cannot be, tell in simplified word because the prices are all governed by demand and supply. So inflation comes in picture. All these things are related. So if diesel prices increased, you will see all your bread and eggs and everything prices will increase because the trucks will have to drive through diesel and the inflation is high, right? So you have naphtha cuts, kerosene cuts, etc. Then on the right hand side, you see catalytic isomerization, hydrodesulfurization, catalytic. So here, catalytic reforming is a major unit which gives you gasoline or petrol, very good quality petrol. Reforming means it is not breaking the molecules; it is just changing that molecule into something else. So if it is a normal paraffin, it will make it isoparaffin or aromatic. So it is just changing the form. It is not breaking the chain. Whereas thermal cracking, or so if you see catalytic cracking, so there is a difference between catalytic reforming and catalytic cracking. Cracking breaks the molecules. Reforming just reforms the molecules. Hydrodesulfurization is another common unit, or it is also called as hydrotreating. So all these hydro units, which starts with hydro, basically they use hydrogen. What hydrogen will do is it will make triple bond to double bond to single bond, right? Unsaturated to saturate. That is the chemistry. And important thing is it will convert the sulfur to H2S, hydrogen sulfide, which is removed out by stripping. So hydro treating units are very important to meet your Bharat 3, 4, 5 specs because it reduces the sulfur inside. So there are many hydrotreating units. Naphtha can be hydrotreated, diesel can be hydrotreated, gasoline can be hydrotreated, and even like gas oils can be hydrotreated. So right now there is a lot of research going on in hydrotreating space because it is very costly. Hydrogen जब आप बनाते हो, that is called as a reformer, steam reforming of naphtha or steam reforming of natural gas. You might have learned about water shift reaction. So hydrogen is produced in a reformer. It consumes a lot of energy, there are catalysts, there are fuels. So you spend a lot of money on producing hydrogen. So it becomes an expensive thing. And now that expensive hydrogen is spread across the refinery in different hydrotreating units. So if that hydrogen is just laid out here and there, the refinery is going to lose money, right? So there are catalytic cracking. Then with we have delayed coker. That is a latest technology because of which people
Sir,
are able to make it. Hello, yes,
sir, but hydrocracking consumes the hydrogen. So how it is favored?
yeah. So hydrocracking is a different unit. So if you see, uh, this is catalytic hydrocracking. So hydrocracking is a very high pressure reaction to produce middle distillates. Hydrocracking is cracking in presence of hydrogen. Okay, hydrogen is not cracked. Hydrogen is
Yes.
introduced in a fixed bed reactor. It reacts with your feed, which may be a gas oil. Lighter gas oil is also called as LBGO or LGO, and that is cracked in the presence of hydrogen. Because if you just crack it thermally, it is going to produce a lot of carbon, and it's not going to yield you much valuable products. But cracking in the presence of catalyst and hydrogen are going to give you very good products. Naphtha, gasoline, diesel, right? So the kerosene that you use, actually, a superior kerosene is nothing but aviation turbine fuel that is used in aeroplanes. It is kerosene grade only, but it has got much superior properties, and one of them is freezing point. Because as you go up in the air, the ambient temperature goes down. So that freezing point should be low. If it is high, suppose it freezes at 30 degrees Celsius or 20 degrees Celsius, your aeroplane will not run. So it has to have a very less freezing point so that in very less temperatures, even below zero temperatures, it should be in the liquid state. And जो भी बर्नर रहेगा उसमें गैस टर्बाइंस जो एरोप्लेन चलाते हैं उसमें वो अच्छी तरीके से फायर होता रहेगा. So these are the properties of major properties. Anyway, did I answer the question on hydrocracking?
Yes, sir.
All right, great. So you have hydro desulfurization. So you have seen this product. Now I'm going to show you another resource. Uh, this is a PDF file. So this is a hydrocarbon processing, and this is a handbook of 2006. I do not have the latest handbook. What it gives you is जितना भी processes are there in refinery. These are all listed here. Okay. So we just saw about catalytic reforming. If I just click catalytic reforming, it gives me a block flow diagram and a very brief one-page summary of that unit. What is that unit? What is the description? What is the typical design? What are the typical operating conditions? Installations, कितने दुनिया में units है? But this is as per 2006, and it gives you a reference. So this is coming from NPRA annual meeting. Or if I go to say again, I go back to home. Say for example, we talked about hydrocracking. Hydrocracking, yeah. Here, here. So what is hydrocracking? Upgrade vacuum gas oil blended with various feedstocks. Products, jet fuel, diesel, very low sulfur fuel oil, FCC ka feed. So FCC is another secondary unit, fluidized catalytic cracking unit. My favorite. So the hydrocracker will produce a stream which will be fed to other unit. So this is a super fun in refinery where the uh, streams produced from in one unit is fed for other unit, and then all these units make similar products, say diesel, and these are like collected in a common place, and that is called as blending. So all these streams are blended in the right amount so that the final blended product uh, adheres to all the specifications of BS3, 4, 5, whatever, right? So there is a description. Okay. So feedstock में पहले जो भी poisons है वो निकाल लेते हैं, because the catalysts that are used in the fixed bed, those are very costly catalysts, and some of them, say for example sulfur or nitrogen or moisture present in the feed, can be poison to this catalyst. अगर catalyst में poison घुस गया, then catalyst will no longer work and you will not get your desired products. As simple as that. So removing those poisonous elements from feed becomes very important. So typically any unit in a refinery would consist of these elements. Okay. One is feed treatment. Get out of all the poisonous things and whatever things you don't want. Then you will have some reaction, conversion. That may be a fixed bed, that may be a fluidized bed, that may be a reformer. So conversion happens in these places. Then you have separation. So once you have converted, it has raw material and product both. There is never 100% conversion of any feed in any kind of process. There is always some percentage of conversion, and some unconverted feed is recycled in every unit. Okay. In petrochemicals as well. So what I told you is feed treatment, then some kind of conversion. It is catalytic conversion, thermal conversion, reforming. Then the next is separation. Separation of components. There are big drums, high pressure separator, low pressure separator, etc. After the liquid gases are separated, there is a series of distillation columns. The distillation columns may be absorbers, strippers, very tall fractionators. For example, the tallest towers in refinery are C2 splitter and C3 splitter. C3 splitter, sorry, C2 splitter is in the petrochemical plants. C3 splitter, because propane and propylene is separated in that tower, and those are very huge structures, or very tall structures, I would say, not huge, tall structures, because propane and propylene relative volatility is less. So it requires more than 100 numbers of stages in the distillation tower to separate those molecules, right? So you have distillation, okay, and then after distillation, you may have some polishing units like MEROX, mercaptan oxidation unit, where you take care of the color, you take care of the smell of the product, you take care of the vapor pressure of the product, some stuff. So that is, those are the polishing units. And after polishing, it goes to storages. The storage is very huge in a refinery. There are maybe 20 to 50 number of storage tanks spread across acres of land. And the crude storage tanks are the biggest. If you see Reliance Jamnagar plant, each storage tank of crude is like a football stadium. Okay, it's as big as football stadium. Now, once you store these products from different units, these are blended. So okay, एक का 10 लीटर लिया, दूसरे का 20 लीटर लिया, okay, kind of, and then that is blended, and that is sent to the marketing terminals of those units. So you have hydrocracking. Then let us look at some other fluid catalytic cracking. Okay, so this is a reactor and regenerator. So there are many designs here. There are many licensors. UOP is one licensor. Stone and Webster is another licensor. Okay, Technip is another licensor. So there are many, Chevron, Phillips. There are many big companies, Pure Daniel. So depending on the licensing, these units designs are different. So I can share this because I don't know from where I got this, but I have it with me. So, or you may find it on internet. I don't know. So you can see there are so many processes given. Sulfur recovery. Sulfur recovery is like, as I told you, like hydrogen units. The hydrogen reacts with sulfur and produces H2S. Now this H2S is absorbed by amine, and these amines are then sent through a regeneration tower where H2S is stripped, निकालते हैं उस amine से, वापस वो amine becomes lean amine, and then it is again circulated in. So that is a closed system. It absorbs H2S, it releases H2S, and once that H2S is released, it is sent to sulfur recovery unit, which is also called as acid gas. H2S and CO2 is called as acid gas, and there is a closed recovery process. You might have studied it. So what we get is yellow color solid sulfur, the product of this unit, which is used in fertilizers. Sulfur is required there, and even that sulfur fetches a good value, maybe 5-10 rupees a kilo, or less or more than that, but that's the price I remember when I was there. So sulfur gives you sulfur product, right? So if you see, there are many now. The pressure swing adsorption, where hydrogen is produced. So hydrogen is what you feed to hydrotreating units is 99.9% pure. It's almost 100% pure. So the technique that you utilize is pressure swing adsorption, PSA. Okay. This is another interesting unit operation. Very interesting. Okay. So this is one file that I wanted to show to you. Now let us move. I think so. 7:30. I think we'll have to move faster. It's already 8:30. So I have shown you refinery schematic. This is another schematic, similar one. So cumulative volume percent. This is a boiling temperature on the y-axis and cumulative volume percent on the x-axis. So if you see, as I shown you, gasoline आता है पहले, उसके बाद naphtha is heavier than gasoline. Then diesel, that is distillate, gas oil, resid. So this is how you get different products from the crude. So I hope this configuration is clear to you. CDO and video are mother units, and there are secondary, primary cracking units, hydrotreating units, catalytic cracking units, and on the right hand side you get all these products. Unit operations. What are the different unit operations? Distillation. Distillation, maybe there are different types: vacuum distillation, atmospheric distillation, steam stripper. Steam stripper में क्या होता है? Basically, RVP is controlled, read vapor pressure. So the lighters are stripped off from small towers. Extractive distillation. This is used in the lube oil manufacturing plants. Absorbers, absorbing, that is H2S absorber. I just mentioned about amine absorber. So amine absorbs H2S. What are the other unit operations? Catalytic reactors. There may be high pressure reactors, low pressure reactors, fixed bed, fluidized bed. Compression of gases. So there are many hydrogen compressors, because that compressed hydrogen has to go to the hydrotreating unit, because those reactors are operated at high pressure. So your hydrogen has to be more than that pressure to enter to that reactor, right? So there are many positive displacement compressors for hydrogen. Pumping is most common. Many pumps, hot temperature pumps, normal temperature, various types of pumps, small, big. Pressure swing adsorption, just we saw. Blending, I just mentioned it. Heat transfer operation is mainly shell and tube heat exchangers, and there are specialized type of exchangers also called as Pacinox exchangers, where those are plate and frame exchangers. Plate and frame, it gives you a lot of heat transfer area in a small setup, and you can get very good approach there, and more differential temperature across this plate and frame heat exchangers. What are the equipments and systems for these unit operations? So I just mentioned about crude desalting in the schematic. Now distillation, there can be tray towers or pack towers. So vacuum especially you will find packed hours because you want to minimize the differential pressure. If differential pressure is high, then the vacuum maintain करने के लिए जो ejectors रहते हैं, their steam is used. So your steam consumption will go high if the vacuum tower delta P is high. There are many big furnaces, small furnaces also there, but the atmospheric distillation have the biggest furnace in the refinery. Boilers for producing steam, centrifugal compressors, positive displacement compressors. These are run typically by turbines, steam turbines, or in older plants there are motor operated compressors as well. So there are two drivers for compressors, pumps, which is like steam turbine or motor, ejectors, steam ejectors, shell and tube heat exchangers, flare system. This is another very interesting topic, flare system, and there are many softwares, Aspen Flare and other. And flare design has got its own. There's again another set of standards to design a flare system. So the flare piping runs across the refinery. So it is very important, and it is the ultimate uh, safety for a refinery. So कहीं पे pressure बढ़ गया column में, या suppose there is a fire, then your hydrocarbons are going to get heated. Lot of vapors are going to form, and those, how do you vent those vapors? You cannot vent it in open. Those have to be burnt at height. At this typical flare height, stack height is 80 meters, 90 meters. So those gases are burned at that much of height. You might have seen traveling through Trombay, Chembur, HPCL and BPCL is there. So on the road, you will see their flares. So those gases are burned at top so that the dispersion is there and it does not affect the resident area. Circulating amine system, that is a closed system. Oh, major oil refining companies in India: IOCL, BPCL, HPCL, MRPL, CPCL. So these are state-run companies, or also called as public sector units. Reliance is a private. Nayara is formally called as SR. Then Russia's Rosneft pick up their stake in SR, and now it's called as Nayara. Global Aramco, you cannot imagine the revenue of these companies. They are in $1 billion. Marathon, ExxonMobil, British Petroleum, Chevron, Phillips 66, Shell, many good companies, huge corporates. So this is published in your Ministry of Natural Gas and Petroleum government website. You can find this table there. So what you have is a refinery location, in which year does the refinery started, and what is the capacity. So if you see, the total capacity of India is 249 million metric ton per annum. Okay, that much of crude is processed in a refinery every year across all these refineries together. So the oldest one is Digboy in Assam. So there is a story that when the crude oil was being explored at that site, and when this colonial leaders, the Britishers and French, they were there to explore the oil, and they had those laborers there. Right? There were no equipment or sophisticated machineries that time. It was 1901. So there were a lot of laborers, and they used to shout, "Dig, dig, boy, dig." Boy, you dig there to get the crude oil, and that's how this name is there, dig boy, dig. So there are many interesting stories. I'll I have this one book. I have that slide last. Worldwide refining, if you see, the capacity has increased from 2006 to 2015. This is the red one. So this is the capacity median. So you can see 82 by 89 million barrel per day. And but you see number of refineries closed down subsequently. What happens is very old refineries, they were very small in size. Now with changing scenario, with changing crude demand, supply, prices, there is a threshold capacity of refinery below which it is non-economical. then the refinery cannot sustain. It cannot sustain. It goes into loss, and those loss-making refineries are shut down. Okay, so that's why if you see Reliance Jamnagar, they have such a huge refinery setup. Then it becomes profitable. The margins are very high. It is all about business. What's the largest refineries? If you see Reliance is there at the seventh number, and Reliance Petroleum is also there fifth. I don't know why there are two, but Aramco is there, Sinopec, Shell, Marathon, Saudi Aramco, Caltex. Okay, so Venezuela has the largest refinery. South Korea has, India, Singapore, Saudi Arabia. What are the products? I think I discussed few of them, but let us go through this. Liquefied petroleum gas, all of us know, cylinder. Propylene, propylene is produced and main producer is FCC unit. That goes to feedstock for a polypropylene, which is a polymer, very high value polymer. Naphtha, naphtha is something like gasoline. Okay, gasoline is a transportation fuel. We know petrol. ATF जो aeroplanes में होते हैं. Superior kerosene oil, domestic fuel, but that is slowly being fade out. Now, kerosene is use is very restricted. No, maybe in villages and all, they may be doing in kerosene, but in urban areas, it is not there. It's no more there. High speed diesel, sulfur, fuel oil, bitumen. Bitumen is damper that is used in road construction. But again, there are concrete roads are being built. So where the demand for bitumen is not much there now. Petroleum coke, as I told you, the delayed coker unit, which processes the vacuum residue, is the most profitable unit, and it produces petroleum coke. Now that coke is can be used as a fuel in boilers. Okay, so if you see, a refinery starts with a liquid, which is crude oil. Gas is utilized. The ultimate solid is also utilized. So basically, it is nothing is vented or uh, as emitted as a solid liquid fuel. Everything is it's zero effluent kind of. Refinery crude and products. So crude का properties मैंने आपको बताया वो ऐसे में. We also discuss IBP, FBP, STM, density, sulfur content. There are specifications. So yeah, octane number and cetane number. So basically, if you are aware, like gasoline engine में क्या होता है? The gasoline and air both are compressed. Okay, so there is an octane number, and it is higher is the octane number, less is the anti-knocking tendency, and higher is the efficiency of the engine, and it gives you good mileage. Diesel cetane number. So in diesel engines, only air is compressed, right? Diesel is not compressed because it is slightly heavier viscous than as compared to gasoline. So they follow cetane number. There is no octane number. ATF, freezing point, LPG, read vapor pressure, naphtha, RVP, PONA, bitumen is a penetration number. So these are just one or two properties I mentioned, but there is a long laundry list of 10 to 20 odd properties for each of the products that is specified. You can find it on all those websites of IOCL, HPCL, BPCL. So this is further reading. EIA is US Energy Information Administration. Okay, so there you get a lot of information regarding worldwide refineries. US के सारे refineries का आपको पता चल जाएगा. Then Ministry of Petroleum and Natural Gas, Government of India. Hydrocarbon processing, you may get some free material there, but most of it is paid. If you get the paid membership, you can get access to a lot of things. EPTQ is free. You can even get the hard copies at your home. You have to register there. OSHA is another like safety and health administration. So there a lot of information is there. Books, there is a book in Marathi, हा तेल नावाचा इतिहास आहे, by Girish Kuber. Is a very, very interesting book. There you will no you will start appreciating this crude oil thing, how it originated and how different world war took place because of oil, how the national geography sorry the geographical boundaries changed because of crude oil, और कितना कुछ हुआ है oil के पीछे आज भी हो रहा है. So there are series of books. एका तेली आणि is subsequent to this तेल नावाचा इतिहास आहे and तेल नावाचं वर्तमान. So there are three books. But if you read this first book, I don't know whether it is there in Hindi or English, but it is there in Marathi. There is a textbook kind of thing by Bhaskar Rao, Modern Petroleum Refining Processes. It is a cheaper book. Otherwise, all other like Will's publication and all, they are costlier. So this is Indian publication. There you will get a lot of information about all the units and properties and everything. Process Engineering for a Small Planet and Troubleshooting Process Operation. These are two books by Norman Lieberman. So Lieberman also has got a channel on YouTube. He is a very old guy and he is very knowledgeable and he has very many years of decades of experience in plants and he has written many good uh, case studies of how the plants are troubleshooted, and the books by him are really entertaining. I mean, he writes like a novel. So they are very good books by Norman Lieberman. There are many other books. Obviously, you can find on like just search and you will get a lot of books. Yeah, thank you with a smiley. Uh, so I think I talked a lot. It's about to be like 9 p.m. Yeah, so now the forum is open. Let me open the chat box and see if there are any. There is one question by Dipti Bari. What factors decide crude presence? Because Asia almost do not have major crude resources. Yeah, so Dipti, it is all, I would say, God gifted. Because Asia, yes, Asia has got crude reservoirs. It's not that we do not have it, but we'll have to spend a lot of on research and development. Okay, and a lot of money on research and development. Then you can find new resources of crude. But it is all hundreds of years that the within the earth those things have happened. So it is really difficult to say that why it is not here and why it is there. It's just like that because Saudi Arabia is gifted with oil. Now US, they discovered shale oil, right? So the shale oil was there, but they invested heavily on R&D and then they found out. So something like in India may be there, but for that we have to spend a lot of crores of rupees in the research and development. Yeah. Uh, Sir, please tell about carbon number. Yeah. So carbon number, okay. The simplest carbon number, is methane. CH4, one carbon and four hydrogen. What is the molecular weight? 16. CH4 is methane. Methane, biomethane. So if you have those all those vegetables and everything compost and deep bury it inside the ground, and if you have a pipe on the top, you get methane. So methane is the simplest form of gas, and it is like carbon number being very low, उसका emission भी बहुत कम आएगा because CO2 will be lesser because carbon is less. As you go on increasing the carbon number in a molecule, the emission will also increase because there will be more CO2, कार्बन डाइऑक्साइड. तो जितना कार्बन कम है और जितना हाइड्रोजन ज्यादा है उतना वो फ्यूल ज्यादा एफिशिएंट होगा, लेस पॉल्यूशन. But we are already putting a lot of money for buying. Can't we spend on R&D? Yeah, Dipti. So I can understand. 80% of crude is imported. It's not that we are not spending, but there has to be like concentrated effort and serious efforts by नो, बिकॉज क्या होता है कि आपने R&D में पैसा भी डाल दिया, बट 100% चांस नहीं कि वहां पे क्रूड मिलेगा. देयर इज ऑलवेज अ प्रोबेबिलिटी. So out of all those wells, maybe some percentage of wells will have crude oil, not all of them. So yes, they are spending. So we have got a few resources, but again, there are lobbies and all. Okay, anyway, this is not a platform to talk about it. But yes, probably you can think of doing some research further in your career. I'm just looking up. Someone has, okay, Ismail Hawa. Crude properties mainly depend on sulfur content, which properties store crude, ultimately its processing expenses. Yeah, I think I have elaborated this during the course that sulfur, yes, it is majorly dependent. क्या होता है? Suppose now Reliance का जो उन्होंने बनाया, they have the good material of construction, MOC. Because if MOC is not proper, with sulfur and other acidic things will eat out the material, thickness will reduce, and the life of the refinery will get reduced. Columns will have to be replaced. So initial investment makes a lot of sense. So Ambani's, they made a lot of investment initially and they put up good MOCs so that gande se ganda crude bhi process kar sakte. If you see the older refineries, these public sector refineries, they do not have that high MOC, material of construction quality. So they cannot process the ganda crude, right? So now Reliance has got advantage. They can process any crude in the world, and this is how that refinery was built. So they have the inherent advantage. Sir, how we can define calorific value of natural gas? So if you want to determine the calorific value, it is done in laboratory. So there is a instrument, I forgot, some bomb it is called as. So there you determine the calorific value, and mostly the gas or the oil, they have some 9,000 to 10,000 kilocalorie per kg. That is a calorific value. Okay, hydrogen will have the highest calorific value, but typically what is the natural gas is used or fuel oil, that is in that range. Why thermal cracking is not used in new refineries? See, thermal cracking is used in petrochemicals, in ethylene complexes. That is the well-known process where you thermally crack naphtha or ethane or propane to make ethylene and propylene. But thermal cracking in refinery, there is only a whisk breaker unit where the the vacuum residue is thermally cracked. But now that process is replaced with advanced technology. The delayed coking is there, right? So delayed coker gives you very value addition products. So that's why the whisk breaker is not there. So ultimately, it is about the game of profit. The thermal cracking will not fetch you much money because it will not make you valuable products. It might make you a lot of fuel oil, but fuel oil kahan bechoge, right? That's the thing. Satish, how shale oil is different from crude oil? Can you elaborate, please? So the shale spelling is not SHELL, it is SHALE. Okay. So shale oil is lighter. It is not like crude oil where you have this range from gasoline till the vacuum residue. I don't think there is a vacuum residue required, right? So shale oil composition is going to be different. Uh, so it is found in the rock. Okay. So is a sedimentary rock. Okay. Uh, So it will also give you diesel, gasoline, liquid, but I don't think it will give you much residue. Okay. So वो एकदम tightly पत्थरों के बीच में फंसा हुआ होता है, and there are some different techniques. I am also not very aware of it, but definitely it is very different than crude oil. So you can read more about it on the on internet. So if I see the images of shale oil, you'll see a lot of yeah, sorry. So uh, did I miss any question here? You can speak. No problem. So I think we have 5 minutes. You can speak.
Yes, those who have any query or the doubt, please feel free to ask.
So Sudarshan, who all are there in the beginning uh, in this session from your team?
Yes, sir, our whole team is present.
Like who are they? What are the names?
Yeah, yeah. Rohan, Onkar, all they are here.
Okay, all right. So yeah, I got one more question. In recent times, most of refinery projects of PSU are to increase capacity of video unit. Is the shift on O2C business, oil to chemicals? Acha. PSU, I don't know because I have visited many PSUs, so there is not much in more capacity coming up. So video basically, see, oil to chemical is bypassing these cuts, bypassing the typical refinery configuration. And then, so oil to chemicals products slate is entirely different. So Reliance might come up in the Middle East, Yansab or some places there where Aramco was setting up oil to chemical first plant, but that has not come up yet. So basically, their products portfolio will be different. It is not to produce petrol and LPG. It is more of petrochemicals and specialty chemicals. Uh, so that chemical, that product slate is entirely different. The future of crude oil refinery, how many years it will sustain? So see, refineries will sustain, but those which are integrated with petrochemical will sustain longer. Now, it also depends on the geographical region. For example, in India, India's transportation is different than America's transportation, right? So now aeroplanes are going to remain there, so you need ATF. So ATF is there. Aeroplanes journey will be increasing in future. Now, in on transportation front, we will still need diesel because India's economy still runs on diesel. LPG might phase out, kerosene might phase out, petroleum coke is still will be there. So the processes, catalyst, and the operating conditions would change to get into the new product slate format. And how many years? It will sustain whatever the life of the refinery. Yeah, and ultimately, the newer capacities that come up would maybe like O2C, that they may come up on that, right? So this is really a market, sorry, the research topic, and no one can exactly predict. Uh, the technologies will be different, but refineries will sustain for longer, and petrochemicals have a great future.
Yeah. So I would like to request the participants who have any queries, you may drop your queries on the mentioned mail ID, that is the info@ beginnings organization. So it's beyond the time, so we have the closure now. So we have the good interactions. So now it's time to say thank. So, on behalf of the team Beginnings organization, I would like to say thank to our honorable chief guest, Mr. Nishat Patil, and all the participants. I would like to express my gratitude to all esteemed delegates of the webinar for their presence and contribution to making this webinar a great success. I extend my gratitude to our chief guest, Mr. Nishat Patil, to take out time from his busy schedule to grace the event and to encourage and inspire us. I must thank the organizing team and the volunteers for working hard for the past few days to make this webinar a successful. Also, I congratulate all the participants for their active participation, and also I will once again thanks to all the participants for making this a great success. Thank you all.
Yeah. Thank you, everyone. So keep learning. There is a lot of information available out there. Keep reading books and increase your knowledge. There are many interesting things, interesting books. I hope I have not bored you, and so I have tried to cover uh, as much important part of the refinery as possible. Though 1 year or so 1.5 hours is very challenging, but I have tried my best. Hope you will find this useful, and if that have triggered some interest in you to read further, that is my success. Thank you very much.
Thank you, sir.
Bye bye. Good night, all.
Yeah, thank you and good night all.